This is a short little video on type 2 errors in power. And we did it in class, but I'm not sure we got to the depth that I was comfortable with in class. And so I just want to have a video to go along with it. And so let's review. A type 2 error is when the null hypothesis is false, but we failed to reject. And that's really the worst case scenario. We were trying to prove that something happened, and we failed at it. We were trying to prove that something was false. It was false, but we were unable to prove it. And that's what's known as a type 2 error. Once again, these errors have nothing to do with how we set up our experiment. It's everything about the results based on the statistics and the probabilities. So we talked about a type 1 error, and a type 1 error is the probability that the null hypothesis is true, but you say it's false. And that's alpha, and that's, you set that at the alpha level. And so type 2 errors. So the type 2 error is the probability that we use the variable beta, the probability of making a type 2 error. And if you think about it, a type 2 error is we failed. The test was false. I mean, the null hypothesis was false. Once again, we're in God mode here. We would never really know this for true, if this were true or not. But if we were playing God mode, the null hypothesis was false, but we failed to reject it. And so 1 minus beta is the probability that we'll get what we wanted, which is the probability that the null hypothesis is false, and we will say it's false. And so that's what's known as the power of the test. Now the thing is alpha we can figure out. Beta, calculating beta is really hard. And it's really not going to be done much in this stats class. It's more of we have to understand the algebraic relationships. So let's look into this a little bit more. So here is our example. Our null hypothesis here, as you can see, this is our sampling distribution based on our null hypothesis that P equals 0.08. Sorry, it says that right here. So this is the sampling distribution of P hat if the null hypothesis is true. And we do a sample. And so anything in here would be, if we get a result in here, that's a type 1 error. But let's say the null hypothesis is false. Let's say the true P is actually 0.177. Now once again, we're in God mode, we wouldn't know that. So then, well, this top one is the sampling distribution if the null hypothesis is true. This bottom one is the true sampling distribution, which we would really never know, but it's going to be centered on 0.07. So the same line where our alpha was, would be where anything above this we're going to reject the null hypothesis. So anything over here is stuff that we would reject the null hypothesis. So any values in here is going to be beta, because any value from here over, based on our original test, right in here, we would reject the null, based on our original hypothesis, which means that there's a chance, which is all of this area right here, that we would fail to reject the null hypothesis, even though now we know that it is actually false. And this area in here is the power of the test. This is any one of these results that we get here would cause us to get the correct answer. And so that's power of the test, and this is just more video on this for you to do it. And so when you do, the only way to increase the power of the test is if the two things that increase the power of the test, if we go back to this thing, and we did this hopefully a little bit in class if we had time, is that the further away the actual value is away from the null hypothesis value. So as this graph slides to the right, the power of the test will increase. If it was sliding, if it was a less than if it was when it slid to the left. The other way we can increase the power of the test, though, is by increasing the sampling size. Because when you increase the sampling size, it will make the distribution narrower, and therefore there'll be less area in beta. So the only two ways to increase the power of the test. So we can decrease our type 1 error by doing alpha, but then we really need to increase sample size. And the basic rule is the higher the sample size, the more likely we are to get a statistically significant result. And here is just the notes on everything that we've learned in this section. Feel free to write it down. It's all straight out of your book. You should definitely read your book on the part on power so that you get this down. I will also answer questions about this next class, and we'll hopefully go over this a little bit more.